So a bit about us. I'm actually a psychologist, but I work in IT, so yeah, that didn't work well. And at Semotex, we have kind of two sides. We have a services side where we do consulting, production, support, and training for Solar and Elasticsearch. And that's where I spend most of my time. But I also fill with our solution called Semotex Cloud, which is like a log management, metrics, traces, that kind of thing, which also has Elasticsearch as one of the backend components. So I stick my nose there at times, and also fill with syslog. I have a thing for syslog, if you want to talk about that.
Don't.
Anyway, don't.
And I'm Rafał. I'm an engineer turned consultant. So we turn sides a bit. And we wanted to give you a few things today. So we wanted to talk how interacting with certain tools affect your brain, how to actually encode information to learn efficiently. That's not something that we know, and we wanted to share that knowledge. We wanted to also tell you how to interact with people and how the interaction with people actually changes and affects the daily routine, and not only. And finally, what is the proposed daily structure that you should go for in order to have the most out of your day and to not like feel stressed at least that much.
Right, so let's start with observability. And this is, of course, like our interpretation based on studies, so, you know, your mileage may vary, just kind of a disclaimer overall. What I would think about observability is that it enables two things that are pretty important for our brain, certainty and autonomy. So certainty has to do with the fact that we're kind of pattern-driven animals. We want things to be predictable. If something goes down at 7 p.m. every day, it's better than if it crashes randomly. If we know why it crashes, it's even better. Okay? Because if we don't, you know, we get stressed up. We get a lot of brain activity in our amygdala, which is the thing that kind of senses whether there's stress in the environment. And therefore, we don't have enough kind of resources to think. So if we monitor things, we're going to be more productive, not only because we can actually solve the problems, but also because we can focus better. And autonomy, of course, if we understand what's going on with the application, and if it crashes, then we have some insight onto why, and we can go and fill things. So autonomy, of course, is also enabled by company culture. But in general, it's important, even if we're kind of stressed out, if we have a sense that we can control what stresses us, things are better. And I have here, done many studies about this, but the one that sticks with me has actually been done on rats. And it goes like this. They took some rats, gave them drugs, and because the rats didn't really eat or sleep, they died. So then they take a second group of rats, and they let them take the same drugs, but by them activating a lever. And what happened was that rats still died, but they died later. So if you weren't here since the beginning, the gist of it is monitor your stuff, you will live a happier, longer life. Thank you. Now about alerts, and here I want to talk about context switching. It takes, you know, if you're trying to focus on something, it takes the brain a while to reach kind of peak performance. And some studies have shown that it takes up to like 30 minutes. And what's more, we're easily distracted. This is kind of, I think, a natural thing. Like picture like yourself 10,000 years ago trying to light a fire, you're trying to focus, and then a tiger shows up. Like, you'd better be distracted. You'd better be easily distracted. And we can suppress distractions. We can say, okay, the tiger's gonna like fill up his own Jira, I'll take it next sprint. But, you know, when we do that, it actually, all the mechanisms for like inhibiting stuff are in our prefrontal cortex, which is the part of the brain that also deals with like thinking, decision-making, things like that. So we're going to take resources from there. It's still, even if we don't actually context switch, it's still kind of a micro context switch. It's still going to take resources. And I think that's where the term alert fatigue comes from, because it's going to be just hard to get into a flow. So that's why, of course, I don't want to be alerted if something isn't actionable, but I want to be interrupted only if it's something like Tiger actionable, right? Like if some server runs out of this space in like 3 weeks, that can be, I can deal with that later. Next thing about using, of course, we want to automate as much as possible. We want to use the best tool for the job. But that, as you all know, it requires some investment in time to like learn new things, to use them. But also, I want to talk a bit about the energy investment, from the perspective of the brain. So the thing about when we first start like doing something, we need to think about every little bit, like think about learning how to drive, or like generally every new thing. So we use our CPU a lot, right? Like our prefrontal cortex. And the CPU, our CPU is actually very, very slow. Like some have attempted to measure different parts of that. First of all, we are single-threaded. We can't really multitask. Then we can only really think about, like consciously think about 3 or 4 things at once. And if we want to pull more stuff from memory, some have actually tried to measure our like read-write throughput to memory, and it's something between 10 or 20 kilobytes per second. So we're actually very slow when we don't know things. When we start learning things, that's when we have like our other neural pathways. We can involve other parts of the brain, whether we visualize stuff or we just like instinctively write some commands or know places where to click. So that's when we are much better. So effectively automate things in our brain. So there's this kind of energy investment because also the prefrontal cortex eats a lot of sugar, and we're going to come back to that. And then the second thing I want to talk about when it comes to learning is what is called the status threat. So if I'm presented with a new technology, like let's use a brand new monitoring tool like Nagios, okay? I want to switch to that because that's the best thing. If I don't know Nagios, I might perceive this as like a threat to my self-esteem, right? Or to just how I appear in front of others. And I might say, well, Nagios crap. I've heard a bunch of guys, saying that they had trouble with it. So I might get defensive. And we are like naturally, it's not like just people that are like very concerned about their egos. This is like a general thing that the brain really easily picks up. That, oh, we might not be aware of it, right? But it's like I don't want to look like a fool. So anyway, that can be a really big barrier to learning. So I'm gonna let Rafał talk more about learning.
So one more thing, let's get a step back, and how our ancestors were learning to actually light up a fire. They were looking into their parents, grandparents, and they were looking into that, and they start a fire, everything was fine. If you didn't learn quite fast, you basically were like those rats that Radu mentioned, you died. Because you didn't have the necessary skills to actually live a longer life. Actually, they died pretty quickly anyway, but still, this is something that you needed to do in order to live. Now, it's not the same thing. Even if we do not know Kubernetes, we'll still live somehow. Some of us better, some of us worse, but still we will live. And the thing is that was in the past. Then, somewhere around 18th century, teenagers were doing stupid things in Austria. Basically all teenagers, at least most of them, do stupid things, but in general they were causing troubles for the government. And the thing is that the government actually thought what to do. And what they did is they invented schools. So they put all the youngsters and the teenagers into the school, loaded them up with so much material that they couldn't have free time for any additional activities, and that's how they solved the problem. The thing is that they didn't want them to actually learn. They wanted them to spend the time to not have any other activities that were hurting the government and the society in general. So, but this is not what we are good at. Our brain needs to encode the information, and the schools currently actually don't, at least majority of them, again, not to say all of them, they don't teach us how to efficiently learn. And there are a lot of studies of how you could actually learn efficiently. The thing is that we have those two parts of the brain. Let's take a higher picture right now. We have a long and short-term memory. The short-term memory is good for like a short-term stuff, right? You typed in the command just a minute earlier and you remember that. However, if you wake up 2 or 3 days later, you may not know it unless you really encoded that well. And the studies show that there are a lot of actual methods that help you encode the information inside your brain. Some of them are good for IT, some of them not as good, and we wanted to talk about a few of them that are pretty suitable for IT right now. So let's get on with one after another to give you an idea. Some of them you already know for sure, but you didn't know that there were actually studies about them. First of all, the apprentice method. Who doesn't know pair programming, for example, right? It is quite common. So the idea is to put 2 people or even more, one group more experienced, let's stick to those 2, one more experienced and one less experienced, so that the less experienced person can gain the knowledge faster. Basically, the more experienced person shows, talks, and so on, and the less experienced person gain knowledge faster. It is said that the knowledge gain is about 30 to 50% faster when gave by a tutor of some kind. For example, your colleague at work or you being the person sharing the knowledge. The key thing is that the actual experienced person also gains knowledge because they share a different kind of views around the problem or for example, the code or the infrastructure part or anything like that. Of course, it takes time. So, so those two people need to sit on the same problem and spend the time instead of working on the different parts of the environment, on the system or the code. So that's the con of that method. The crash test methods, on the other hand, is probably you also do that. Who didn't do performance testing, right? So you start with some basic knowledge or even more extensive knowledge about the system, and you do a set of tests to actually learn how that given system is behaving in a certain scenarios. You learn the bad and the good points about the system, you know its limits and so on, and that way you encode that information inside your brain, so you'll, as your experience. New neural pathways are developed by your brain, and that way you can actually, you don't need to do the same test on a similar environment once that is in your brain. What's more, you will be able to, like, as a consultant, for example, for us, you know that experience stuff that, okay, we come in and we say, okay, we see some parts will not work because of that, that, and that. That comes with experience, and that's when the crash test method are helpful. The bad side about them is that you need that basic knowledge. Otherwise, the conclusions that you will get out of that performance test that you do, for example, may be misleading. So that's something that you need to remember. Oh, come on. Denser method. So one of those things that you imagine you are taking a book about managing Unix systems, 1,200 pages, you go from top to bottom, you close it up, and you start managing your Unix systems. I guess, at least for me, I won't remember 95% of what I read. So the key point here, and actually the studies show that most of us will not remember 90% of the things. The best ones tend to forget 70%. So 30% only stays in the brain. So the key point here is to actually take the piece of knowledge and go step by step. Take the piece of knowledge, start practicing. Another piece, and start practicing. So just like a dancer, right? You learn a step, then you practice it. You learn another step, then you practice it. And then you combine that into a more extensive knowledge, taking more harder stuff on yourself. That way, again, neural pathways can be developed inside your long-term memory, and you can automatically use that stuff eventually when you learn it actually not hitting that bottleneck that Radu mentioned, about 20 to 30 kilobytes per second between the short and long-term memory inside the brain. This is one of those things that is not a direct learning method, but encouraging the team or the people inside the team to actually learn. So we all know that we have our own pieces of environment or some larger piece of environment. Anyway, some piece that we manage, develop, or anything like that. And that creates a comfort zone. We're good there. Nothing will surprise us. And then eventually a manager comes or someone else and says, OK, now you'll switch from here to that other piece of infrastructure and manage it with, of course, other parts of the team. So you switch places. Of course, it brings initial stress, but then it encourages you to give some additional brain activity and to actually encode new information. Combined with other methods, this is a way to actually extend your knowledge more and more by switching your places. Of course, we won't take accountant and say that right now you start coding, but for example, you can switch programmers from project to project, and that will, of course, don't get me wrong, don't do it like once every week. People need to actually sit down, learn, and so on. They need time. But in general, this is how you encourage people to learn. Parrot method, especially useful for us, like we do the talk today, and we need to prepare somehow, right? So if we will be giving a talk, if you want to share your knowledge during any kind of lightning talks inside the company or anything like that, just rehearse. But the rehearsal needs to be not like you stand in front of your computer, you take the notes, and you just read it loudly. No, that's not how it will work. You need to combine that with some kind of emotions. The thing is, it's said to be the best to actually imagine yourself in front of the crowd that you'll be speaking to and try to learn and imagine yourself inside on that stage and trying to give a talk once, twice, hundreds of times, like, for example, Jobs did before the Apple keynotes. That is efficient in a way that it develops brain activity, it develops brain pathways, but only when combined with emotions. That's the key point here. And it takes time. So again, as with most of those methods, the time is that factor that you need to take into consideration when doing those. Mastering method, one of those things that we usually forget. So pen and paper, simple as that. When you learn a new thing, just take notes. It not only helps you like getting back to the notes themselves on a pen and paper, but it also, when we are writing, we develop new connections inside our brain, making that quite efficient when it comes to learning. But it doesn't work when you take notes on your computer. So that's not the thing. We need to write. Otherwise, we won't develop the neural pathways. That's how the brain works, actually. Box King method, one of the last things that I wanted to tell you is not to dig too deep initially. So if you're, again, getting back to this Unix systems example, if you would start by tweaking kernel and you wouldn't know anything about the Unix systems, then you would probably not learn much. So start tweaking kernel and not knowing about how to create new user or set up networking is not much of a learning method. So instead, take a step, learn the basics, go further. It's like with why the good books about, for example, programming and so on, start with Hello World. That has a purpose, because you start with the basics, then you go on with the conditionals, loops, and then you are introduced to a more complicated stuff, unless you are reading the documentation that just goes right away. But that's the thing. And finally, Tutor Method. No, I'm not sure how you think about it, what you think about it, but for example, for me, it's very effective to, once I learn something or I try to learn something, I try to be a tutor for myself, and when I learned a part of the information, I try to explain it to myself, like I would be giving a talk, a lesson, or a lecture. That way, not only I can see where the gaps in my knowledge that I just learned are, but I also develop the neural pathways again because of how the brain works and how that can be combined to the actual learning thing.
All right, so meetings. There are obviously some downsides. One of which is context switching. So if you have meetings throughout the day, it's obviously going to be harder to get into a flow where you do other things. Then it can also become a status threat. If there's someone that's constantly telling you what to do, then you may get defensive, or we might think that things are boring. But there are also upsides. It depends on what kind of meetings, and I'll try to cover a bunch of categories here. So if I'm meeting someone new, let's say I have a new client, it's going to be better if I meet that person in person, or at least have a video call, because when you meet someone new, because we're this kind of like pattern-driven animals, we want to know upfront, whether that person is a friend or a foe. That's why we say first impression matters. And the default is foe. If we don't get positive stuff from that other person, we might think that that person is unfriendly. And if we can see the facial expressions of that person, that's when we can get a more accurate assessment, let's say. Then, of course, Rafał talked about pair programming. Solving problems together has been proven to be more efficient if we collaborate. And that. Another category of meetings are planning, and I wanna talk about that separately. So again, pattern-driven animals, we want to know what's the context in which I'm working. If I don't have a plan for what I want to do in my day, in the background, my brain will constantly seek for a plan. So that's going to take resources, which is why it's nice to set up a plan up front, because then we're going to kind of run within that context. Now, of course, daily stand-ups can get sidetracked. In this particular example, it can be, again, a status threat. If someone shows up and just kind of takes over the whole meeting, people would probably back off. But the value of planning is there, and if you can do it in the morning where you're on fresh brains, I think that's also going to be good, because planning itself is pretty resource intensive. It requires a CPU. For longer term planning, I would like to touch on estimations. And because the thing is, if we can't meet our goals, we're going to get a strong away response from the brain. So it's going to be like this stress response where we just basically want to back off from that task. We want to kind of fight it. We're going to procrastinate next and things like that. If we meet our goals, we get a bit of dopamine, which is the hormone of addiction. We kind of want to do more of that. And if we exceed our goals, that's when we get a strong towards response. That's when we feel really motivated. So I think it's important that estimations are conservative, and that's why it also pays off to break a bigger item into smaller items. Provided that you can meet the goals, you can get the ball running faster. When it comes to reviews, I would want to talk about feedback in general, whether it's post-mortem, yearly review, or a PR comment, or what have you.
I miss a hat.
You missed the hat. So the thing is, we are naturally wired towards seeing what's wrong. And we are also naturally wired toward controlling things, which is why, if we ask for feedback, we incline to basically say, oh, you did this wrong, and you should do it this way. And then we realize that's impolite, and we wrap it up in this constructive feedback. And this is, I think, the reason. And this obviously creates a status threat, invites the other for like a status threat. And it's really easily picked up by the brain, and that's, I think, the main reason why constructive feedback often doesn't work. People just don't take that kind of advice. And it's also probably why micromanagement is so bad, because it has been proven that even the simple presence of someone with a perceived higher status is actually going to lower your ability to focus. It's going to move more of the activity into your kind of fight-flight mechanism and off of your CPU. So what works better? I think it's going to be obviously more difficult, but like so like kind of asking questions or just in general facilitating change in the other, it's going to work better. If they have their own insights, it's going to be better than if you shove your own insights into them. And it also pays off, to let's say own our concerns. So like there's a pretty important difference in how I frame, like let's say Rafał codes something and I'm like, this is memory intensive. If I put it like, this is too memory intensive, you need to fix that, it's very different than if I say, look, I'm concerned that this is going to take too much memory, it's going to run out, it's going to crash, and it's going to wake me in the middle of the night. So if I own this...
You say you code better than me, right?
That too, but that wasn't the focus.
That's a status threat.
So yeah, but if I own what my concern is, that's gonna lower the status threat, and so will sharing my feelings. Like if I say I am concerned, that's gonna invite him to be more empathic, and that's gonna. He's not that way, but anyway, it's gonna invite him, and that's also gonna lower my status threat. And another thing I want to say about feelings is that they happen anyway. So the activity within the brain happens anyway. Whether we're aware of what we're feeling, like if we're anxious about something, we might suppress that, and that will use, again, CPU, but the activity will still be there. So it pays off to kind of raise that into our awareness, whether I'm speaking about it or not. If I'm aware of what I'm feeling, that's going to shift activity from my limbic system, which deals with emotions, to my prefrontal cortex, which deals with thinking and decision making. So it pays off to actually try to control behavior, so like what is this feeling telling me and what am I going to do about it, as opposed to trying to control the feeling itself. Let's switch gears and talk about what our parents say, sleep well, eat well. If we're not sleeping enough, our amygdala, which is like our stress receptor, is literally going to grow. It's going to be larger in the morning after you had a not such a good sleep. And also our brain eats a lot of sugar, and it overall in terms of energy, it consumes about 10 times more than the average tissue. So those two things combined sort of gives us a typical pattern of when we are or aren't as productive, as able to focus, not necessarily as productive. Because in the morning, once we boot up, which takes about 1 or 2 hours to get really up to speed, that's when we can focus best. That's when we can solve important problems. And by the way, about this boot process, it's important not to jump on a screen right away or press the snooze button. Pressing the snooze button is pretty much like resetting during the boot process. It's at best going to delay things. At worst, you're going to break something.
It works on Windows.
It works, of course. So anyway, so in the morning we're most productive, and as we get towards lunch, of course, like right now, it's more difficult to concentrate. Then after lunch, we can tap into that new energy by doing something more stressful. Stress isn't necessarily a bad thing. And then again, towards the end of the day, it's going to be more problematic. Reading emails in the morning, just because of the same thing, can be a bad thing, because we can use that sweet spot of energy to deal with things that may or may not be as important. So if we can time box it and use it for planning, that's probably going to be helpful. If it drags on to most of our day, then it's probably going to create a bit of a mess. And last but not least, we've been focused a lot about how to kind of maximize activity within our prefrontal cortex, how to be productive. But actually, there are times if we have lower overall brain activity, like we do with context switching. Rafał mentioned switching places. That's when we have lower overall brain activity, that's when we can get more insights. That's when we're the most creative, provided that we are not stressed. So yeah, I'm gonna leave with that. It depends.
So we don't have time for questions, but if you have any, we have a booth here. Come talk to us about that. Come talk to us about containers, monitoring, logging. We are also hiring.
We have 3 minutes for questions.
Oh
I have
my
good
God.
news.
This is what I call a status threat. But this is Radu, I'm Rafał, and thank you for listening.
Thank
you have
you.
our contact if you want, and we have time for questions, apparently. So, thank you.
Thank you.
Tiger.
Sorry.
Any questions? One in the middle.
Yep. Into open plan offices. So the question was, we talked about how the presence of someone with perceived higher authority kind of interferes with our ability to focus, and how does that tie with open plan offices? I don't know, I guess it's up to interpretation. If it's more likely that someone with higher status will just come up your back and look at how you're coding, then I think that's going to be a bad pattern, I would assume. I'm not sure if that answers your question, though.
That depends, I think, on the organization itself as well. The problem is that if you have like a place where you feel comfortable, your stress will be lower. And but if you have like a manager or a higher, like your boss or anyone, just near you or looking at your back, that will lower your performance in general. You will try to stick only to like doing the things that you should be doing, not any kind of like opening something and trying to search for knowledge or anything like that. You'll be focusing. That may not be that good for your brain in general. You'll always have something there in the back that will say, "Watch out, I'm there." Tiger.
Yeah, I mean, it's obviously also contextual. Like, if the company culture is so that it tends to lower the status threat. So, like, if people are not trying to shove their own sort of opinions on you and are kind of more relaxed, then I guess that will definitely help. Any other questions?
Anyone else?
Status threat.
No? Oh, wait.
Yep. Okay. Yeah. Mm-hmm. Yes. I can look them up and hit me on Twitter or email, and I'll because the thing is, it's about like our fine motor skills that are involved when you write, which are different than when you type. So when you write, you're going to just basically use more of your brain, and that's going to help with encoding information.
Basically, all those methods that we've mentioned about learning, there are research on that. If you're interested in that, we can share the papers, actually. Yeah. There are really a lot of interesting stuff there. That, for example, when I was reading about it, I was surprised that it actually works that way, because I would expect completely different, but it actually shows that it works. They were taking like groups of people, dividing them and showing the same exact material, and the group in that particular method, in the mastering method, the people that were actually writing were like 15 to 20% more effective about remembering the information, and the key point here is after a longer period of time. Because it doesn't actually help you with with the short-term memory. What it does, it helps you with the long-term memory when it encodes that information for you. So this is where it helps. We can share the papers. They're really, really interesting.
Yeah, pretty much all we said here is kind of backed up by studies. So if you have any questions about something in particular, like definitely we can share that.
Hello. Is this on? Okay. Coincidentally, we actually have dedicated Slack channels, one for each of the each of the talks.
Awesome.
So if you have resources to share, please drop them in there.
Yeah, sure.
Cool.
Okay. Thank you very much.
Thank you.
Thank you.